In this module, we will learn about oxygen concentrators. You will learn the basics of oxygen concentrator, the need for oxygen concentrator, its clinical uses, and the principle on which the machine works. We will also discuss the maintenance, upkeep, and the running cost of oxygen concentrator. Finally, we will discuss limitation and precautions pertaining to the equipment. Oxygen therapy is life-saving for neonates and children in several respiratory illnesses. The most common indication of oxygen therapy in newborns is respiratory distress, while pneumonia is the leading cause of death in children less than 5 years of age in most of the developing countries. So, a source of oxygen is mandatory for treatment of newborn and childhood illnesses. Oxygen concentrator is one such device made to meet the need of oxygen for such conditions. Let us now discuss the clinical uses of oxygen concentrator. It can be used as a source of oxygen for pneumonia in small hospitals which require oxygen therapy due to lack of oxygen cylinders or centralized oxygen source. Second clinical use is in sick newborns with systemic illness to maintain normal oxygen saturation. In infants and children, it is used for lower respiratory tract infections like pneumonia and bronchiolitis. It can also be used for preterm neonates with chronic lung disease who are oxygen dependent at discharge. Here, oxygen concentrator can be used for providing home oxygen therapy. Let's understand the principle on which an oxygen concentrator works. The air sucked in from atmosphere, which contains 21% oxygen, passes through two filters, namely external coarse filter and the compressor inlet filter. The main function of these filters is to remove dust from the atmospheric air. The dust-free air then moves into the compressor, which forces the air into canisters. These canisters are filled with zeolite, which is aluminium silicate. This compound has a special affinity to bind nitrogen and separate oxygen. The nitrogen is liberated back to the atmosphere. Two canisters are used in one oxygen concentrator because the period of oxygen outflow from one coincides with the discharge of nitrogen from the other, so that a continuous supply of oxygen-rich gas is delivered to the patient. The oxygen-rich gas is stored inside the oxygen reservoir and moves through the bacterial filter to the patient through flow meter. So, the patient gets concentrated oxygen to the tune of nearly 93 to 95%. After knowing the clinical uses and principle of oxygen concentrator, let's now discuss various components of the machine. The size of oxygen concentrator is like a small refrigerator. This is the air inlet which is present at the back of the machine. This air inlet is covered with coarse filter which removes the dust from the air. This air then moves into the compressor inlet filter. The inlet filter is made of fine particulate synthetic material known as felt. It removes the fine dust particles from the air. The dust-free air through this filter moves into the compressor. The compressor, as we can see, is present at the lower part of the machine. There is a fan at the side of the compressor which keeps the compressor cool. The compressor forces the air into canisters. These two are the canisters. These canisters contain aluminium silicate. This is the oxygen reservoir where the concentrated oxygen is stored. This is a bacterial filter which is attached to the oxygen reservoir. When needed, the oxygen flows through flow meter and is delivered to the patient by prongs. The capacity of oxygen concentrator varies. This concentrator produces a 10 psi pressure and has a single flow meter, while this oxygen concentrator produces a 20 psi pressure and two flow meters can be used with this concentrator. A flow splitter is a device which splits the flow of oxygen to multiple babies. This can provide oxygen to 4 or 5 different babies at the same time. Each baby can receive different flow rates. It is connected to the outlet of an oxygen concentrator. The oxygen is delivered through plastic tubings connecting the outlet nozzle and the nasal prongs fixed to the patient. It is important to know about the proper use of oxygen concentrator. We will now discuss the steps for using the machine. Once you have plugged the power supply, switch on the concentrator using the on-off button as shown. Once the concentrator is on, a yellow light will come up. Next, adjust the flow to 3 to 4 liters. This light will be on till the desired concentration of oxygen is achieved, which in most concentrators is nearly 90 to 93%, after which the light goes off. Every manufacturer has its own way of showing the achieved desired concentration. In some concentrators, this yellow light will become green after achieving the desired concentration. Once the oxygen concentrator is on, connect it to the patient by using appropriate sized nasal cannula. Ensure that there are no air leaks and the nose is clear. If required, instill nasal saline drops. If pulse oximetry is available, monitor oxygen saturation along with the other vitals. This is the whole setup of oxygen concentrator supplying oxygen to the baby through the prongs at a flow rate of 2 liters per minute, and we can monitor the saturation through pulse oximeter. Let's know how to maintain our machine. This is essential as it will make the machine more efficient and also increases its life. The device is as simple to manage as it looks. We need to follow simple steps to maintain the machine. The coarse filter has to be washed every day. You will notice lot of dust blocking the sieves. The inlet filter has to be replaced after 6 months or 1500 hours of use. This filter should never be washed or should come in contact with water. It should be cleaned by dry tapping only. The filters may be changed according to local conditions depending upon the dust and humidity. The life of the zeolite crystals is expected to be nearly 20,000 hours, which in most situations would give about 10 years of use. The fourth filter, that is a bacterial filter, must be changed once in a year. Every concentrator has an hour meter. The working hours should be written down in the service report. The concentrator may work 24 hours a day, every day, as long as the daily maintenance procedures are carried out. Every equipment has its own limitations. In general, oxygen concentrators have few problems during use, but it is important to be aware of them. When air is hot and humid, as may be the case in many tropical countries, the concentration of oxygen may be reduced to 70%, as in these circumstances, moisture is absorbed by the molecular sieve material in preference to nitrogen. Secondly, low voltage may pose a similar problem by overheating the machine due to the inefficient running of the motor. A voltage regulator should be used in these circumstances. Third limitation is when we use it at high altitudes. The concentration may be reduced to 80% due to the low oxygen concentration in the air itself. But this should not cause serious difficulties in most cases. Lastly, the concentrators are not intended or suitable for compressed gas anesthesia machines or ventilators. Another limitation of oxygen concentrator is that the oxygen concentration goes down as the flow keeps on increasing. If the flow is at 1 liter, the oxygen concentration is nearly 96%, which drops down to 95% at 2 liters 91% at 3 liters, and to nearly 87 to 88% at 4 to 5 liters. It may not be a major problem with current oxygen concentrators, which can achieve the oxygen concentration of nearly 96 to 97%. When a flow splitter is being used, the total flow should not exceed more than 5 liters, else the concentration of oxygen will decrease. This happens because the canisters have a defined volume and can only separate a known volume of nitrogen at a given time. Let's now understand precautions to be taken while operating the machine. The concentrator should be placed as far away from the window as possible to avoid dust and moisture. It should be kept far away from open flames. Remember that oxygen cylinders must be available as backup for oxygen supply. In case of power failure, the oxygen reservoir provides oxygen for only 2 to 3 minutes. Let's discuss some troubleshootings which are likely to be encountered while we use oxygen concentrators. If the machine is making too much of noise, check the coarse filter. This may be blocked with dust, so compressor has to work hard to suck the air. It may need to be cleaned, so wash the coarse filter. If there is too much heating of the machine may be too near the wall. One should always keep it away from the wall, else it will decrease the efficiency of the machine. If one uses too many compressors in a room, the room temperature may increase. So, best is to house them outside the room or in open space. Another problem can be that yellow light is not going off, indicating that the desired oxygen concentration has not been achieved. It may be due to high humidity in the atmosphere, or the flow rate is more, which exceeds the capacity of zeolite material. If compressor is producing too much heat, it may be due to malfunctioning of the fan, which cools the compressor. In that case, the fan needs to be repaired. These are some of the companies which supply with oxygen concentrator. The initial cost of the concentrator is nearly 45,000 to 50,000 rupees, which may be considered expensive in comparison to cylinders. Nevertheless, the yearly running cost is substantially less, nearly 12,000 to 15,000 rupees, as compared to oxygen cylinders, which cost 2.5 to 3 lakh rupees. Thus, on cost alone, the oxygen concentrator is the preferred means of providing oxygen treatment in developing countries. Before we end, let's brief what we learnt in this module. We know that oxygen is required for many respiratory illnesses in babies, and oxygen concentrator is an efficient and cheap alternative to oxygen cylinders. We learned how an oxygen concentrator works, its principle, and also its various components. Lastly, we should remember the limitations and the various troubleshootings of the machine. Hope you learned and enjoyed this module. Thank you.